Hi everyone. In this video, we are going to discuss about stack implementation using array. So stack operation algorithm we are going to cover in terms of its operations like push, pop, peek and two helper methods which are isEmpty and isFull. And we will talk about time complexity of each operation and we will see how stack operations are going to be performed using some example dry run. So before writing algorithm, just to understand more clearly, let's consider a use case where we are having stack of balls. So this is like a container. So this is the container in which all three ends are closed and only one end. This is the open end. So only from this open end we are going to push or pop the ball. And here each ball is going to occupy the same space. So this is ball 1, this is ball 2, this is ball 3, right? So if you notice it, the same thing we can transform it as this is for ball 1, ball 2, ball 3 and assume that there is a place for one more ball. Ball 1 B1, ball 2 B2, ball 3 and one place is empty currently. And instead of starting the position from 1, I am going to start from 0. 0, 1, 2. So this is what exactly array representation, right? So the same thing, stack of balls, we just converted to array of balls. But here, in case of stack, we are going to allow push and pop operation only from one end, right? But array means we are having the flexibility to access at any position. We can delete element at any position. We can add element at any position and we can modify. So that means the same array we are going to make some condition so that it is going to accept both push and pop operations only from one end. So now before going to implement stack data structure using array for these operations, let's try to aware what are the points we have to remember in case we are using array. So in this first one is fixed capacity. We know that array is static in nature because this is just a static size array. So once array size is fixed, we can't able to grow the size of the array, right? So that means that stack can hold maximum of n elements. Here in this case, n equal to 4. And this n has to be given during the initialization of the stack itself. Second point, suppose here we are going to add one more ball B4. Let's assume that we are trying to push one more ball B5. There is no place left in this array to push one more ball, right? So this case overflow happens. This overflow we are going to check using is full or not. Is stack is full or not. Once the stack is full, it is not possible to push any element into the stack. For example, this is the array and initially we are having size 4, but we have not pushed any element into the stack. So that means that there are no elements present in the array. Suppose we are going to get operation that we have to perform pop, which is not possible, right? Because we don't have any element into the stack. So this is called underflow. So if there are no elements, simply we are going to throw exception or we are going to return null value. These are the points which we have to remember while implementing the stack using arrays DS. Now let's write algorithm for stack operations. So first one is for push operation. First we have to know what is the value of n, means at max how many balls a stack can hold. So let's define n as 4, n equal to 4 and initially our stack is empty, right? So to understand how it visualized, let's draw like a container where we are going to have total capacity of 4. So here when we are going to push an element, so where first it will be inserted? Obviously 0th position. So this is the B1. Suppose I am pushing ball 1. So first it is going to occupy at 0th index, right? And I am pushing one more ball. Then it is going to be B2. And this is going to be the top element. And suppose if I remove B2, then this is going to be the top element. So here only top element is going to be changed whenever we are performing pop or push operation. Just by knowing the index where our top element is, we can easily perform both push and pop operations. So here initially our stack is empty, right? Then what is the top index? So here we are going to use one variable which is top. So initially top is going to be, because there are no elements present in the stack, means top is going to be -1. So here it is going to be pointed out. When a new ball comes in, then first we have to put it 0th index. That means that first we have to update top equal to top plus 1 and we have to insert at top index. Stack top equal to B1, whatever the element we are going to get it. So now let's write algorithm, the same thing what we have performed here. So push operation, void push, and we are going to get data. So in this case it is a ball. What we have done here, first we have incremented top, right? Because initially top is pointed at -1. We have to increment first to top. So top equal to top plus 1, and here array we are representing a stack. So stack index top equal to the data whatever we are going to push it. Is it enough? No, right? Suppose we have already seen the assumption that once the stack is full, it is not able to push any element. So what we have to do, if stack is full, then simply we have to throw exception. So this will be executed if stack is full, otherwise these two lines are going to be executed. The second one is pop. So here now we have only one element B1, only one ball B1. When we call pop, so it has to remove the top element only, right? So now to understand pop, let's push B2, then this is the top index, and again B3, then this is going to be the top from here to here. Now we want to perform pop operation. Again we can able to perform from this open end only, because this end is completely closed, right? So then what we have to do, we have to remove B3. So that means that how we can able to access this B3, again using top index. So first we have to get what is the element or ball at top index. So I am getting ball equal to stack top index. So once this ball got removed, then what is the top of this stack? Obviously B2, right? So top has to be updated to B2. So that means we have to decrement our top variable, top equal to top -1. So now let's write the same thing here. So here we have to get the data. So I'm just giving the type as data and then pop, right? So what we have done, first we have retrieved the ball which is at top index. So ball equal to stack top, and the top element is going to be changed to the previous top. So we are going to update top equal to top -1. Let's assume that this is the stack currently. We have performed pop, then B1 is going to be removed and top is going to be updated to -1. Then again we are trying to perform pop operation, which is not possible, right? Because there are no elements present in the stack. So that is underflow. So for this, what we have to check? Whether stack is empty or not. If stack is empty, just we have to throw exception. So before performing this operation, first we have to check whether stack is empty or not. So if stack is empty, then throw exception. If not, so if it is empty, these two are going to be executed. If not, these two lines are going to be executed. Here we have mentioned that each stack is full and each stack is empty. But how are we going to check these two operations? So that is what we are going to write now, algorithm for is full and is empty. So third one is full. So the method signature will be boolean is full, right? Here, what is the max capacity? N equal to 4, right? So to understand is full or not, let's perform it. First, I pushed ball B1. Then this is my top. Then I pushed ball B2. Then this is going to be top index. Then I performed again push B3. Then this is going to be top. Then again I performed push. Then it is going to be top. So once top reaches 3, so here top equal to 3, then the stack is full. So what is the capacity here? Total 4. So if top plus 1 equal to n, that means that our stack is full. The same thing, let's write here. So here we are just checking whether top plus 1 equal to n. The index top plus 1 equal to n, that means stack is full. So next one is empty. So again here also the method signature is boolean is empty. So initially what is the top? We have assumed that top will be at -1, and whenever we are going to perform pop operations, automatically top is going to be reduced by 1, and again if we remove all the elements, means again top will come to this position, which is -1. So it is going to be simply when top index equal to -1. And we need to talk about one more operation, which is peak or top. So this is nothing but we just want to interested in knowing what is the top element present in the stack. So how do we get it? Just by accessing the element which is at top index, right? So here the algorithm is, we have to return the data, whatever it is, int peak, and we are going to return simply return stack and then top index. Whenever we are going to returning stack top, means again there can be possibility that top is -1, that is if stack is empty. So here also we have to add one more check. If is empty, simply throw exception. So just by using the top index, we are performing both add and delete operation, and we are not allowing to add any other place. So that is how array is being used to achieve stack kind of data structure, which is using last in first out manner of operations. So here if you notice it, just we are using the top index everywhere, right? So we are keep on updating top index depending on the operation, and just by using the top index we are performing all the operations. So the time complexity for each operation is obviously order of 1, right? Now just understanding these operations, let's do dry run using some set of operations. And here let's assume that initial stack of size is 4. And initially top will be pointed at index -1. So first we are going to push B1. Then what it is going to be? Top will be updated to top plus 1, which is 0th index, and we are going to update B1 at 0th index. Then push B2. So now top is at 0th index, right? So first we have to update top to 1, and then we are going to push B2 at top position, which is index 1. So B2 also perform. Then push B3. First we have to increment top by 1, which is 2, and then we are going to insert B3 at second position, which is here. Then we are going to push B4. Then we are going to increment top by 1, which is 3, and we are going to push ball B4 at top position. Then we got again one more push operation, which is B5. Then before updating top, we have to check whether stack is full or not, right? So here 3 plus 1 equal to 4, which is equal to n. So top plus 1 equal to n. So that means stack is full. So here we are going to throw exception. Then we got one more operation, which is pop. So now what is the current position? What is the current position of top, which is at index 3, right? So we will get what is the ball, what is the element at index 3, which is B4. So B4 we got it, and then we are going to decrement top by 1, then top is going to be 2. So this ball is removed. Then again we got push B6. So then what is the value of top index, which is 2, right? So before pushing it, we have to check whether the stack is full or not. Yes, obviously stack is not full because one place is left, and then we are going to increment top by 1, then it is going to be again 3, and then we are going to insert B6. This is how the stack operations are going to be performed using array data structure. So what are the limitations? So the limitations obviously based on the static array limitations, because the size is fixed. Only at max n elements a stack can hold. How we can overcome this? So to overcome the limitation on static array, we have used dynamic array and we have used linked list, right? So similar way, the stack data structure also we can implement using dynamic arrays, or we have used one more data structure, which is linked list. The same way, even stack also we can implement using concept dynamic arrays, or we can use the data structure linked list. So in this video, we just covered how we can implement stack using static arrays. So in coming lectures, we are going to implement using dynamic array, linked list, and we are going to write the code for this using Java programming language. I hope this video is helpful to you. Thank you for watching. Stay tuned. Happy learning.